Welcome to the new unit of trigonometry. Trigonometry is a very important unit. Although people think that trigonometry is really based on triangles, we will explore all angles. We'll even get into where trigonometries are represented in circles and even waves. So trigonometry is really important for physics for component analysis or even measuring waves. So let's just get started in trigonometry and see where it takes us over the next couple of weeks. Definition. We will be building our unit upon a definition, and that is the definition of an angle in standard position. An angle is in standard position if its first side, called the initial arm, is a ray from the origin along the positive x-axis. So in my quadrant 1 picture, I'm just going to draw the initial arm. The initial arm is a ray along the positive x-axis, starting from the origin. The second side is called the terminal arm, is any ray from the origin. So if we again begin from the origin, if we have an angle in quadrant 1, the terminal arm will be in quadrant 1. The ray starts at the origin and really can go anywhere. The angle in standard position is measured from the initial arm to the terminal arm. So that is, we start from the initial arm and we go and we measure until we hit the terminal arm. If measured in a counterclockwise, so counterclockwise is in this direction, the angle is positive. But if we measure in a clockwise direction, the angle is negative. So what I have just drew for you is an angle that is a quadrant 1 angle that is in standard position. So we have the initial arm and we have the terminal arm. So all angles in quadrant number 1 are better known as acute. So let's take a look at quadrants or angles in quadrant number 2, where theta is between 0 and 180. Again, I'm going to start off with my initial arm being a ray along the positive x-axis. My terminal arm will be a ray starting from the origin but going anywhere. And since I want it in quadrant 2, and my measurement of my angle is going to be from the initial arm to the terminal arm. So far, what I've just drawn for you, this theta might be equal to 110 degrees, for example. It's in quadrant number 2, greater than 90 but less than 180. And later on, what we'll see is sometimes we can measure theta in the opposite direction. And so this way, if it's measured in a clockwise direction, it might be theta is equal to 170 degrees. Something like that. Actually, I'm going to change it to 150 just for ease of argument later on. All right. So quadrant 3 angle in standard position. Again, we have an angle along the positive x-axis, and we have a terminal arm that goes in quadrant number 3. And if I want my angle to be between 180 and 270, it implies that it's positive, right? It's positive. And it's from the initial arm to the terminal arm. If I can revisit my quadrant 2 angle now, my angle had to be between 90 and 180. So I'm only talking about the purple arm here, not the negative, because theta had to be between 90 and 180. Quadrant 4, let's move on there. There's my initial arm. Wish I had a ruler, very difficult. But if I know that my terminal arm is between 270 and 360, it's going to terminate there. And we have to measure it in a counterclockwise direction, and that's theta. Now, I'm just going to remind you of the fact that might help us out. That would be 0 degrees. If I have an angle that is right to 0 degrees, that's going to be 90 degrees. This will represent 180, and this would represent 270. That's just an interesting conversation, is it not? Let me just get rid of all the near information I have here. So if this is where I start, a right angle would represent 90 degrees. If I measured all the way across, it would represent 180 degrees. Now, if I'm down here, it would be 270.